Hi, I'm Bob. Welcome back to 5-Minute Econometrics, a program focusing on fundamental econometric concepts and estimation methods. Today, we will explore the Lagrange Multiplier LM statistic and the LM test. In previous topics, we have learned the t-test and the f-test. The LM test, like the f-test, is used for testing multiple exclusion restrictions. The difference between the LM test and the f-test is that in the f-test, we estimate the unrestricted model and the restricted model. By contrast, in the LM test, we estimate the restricted model and the auxiliary model. We will compare them with an example later. How to do the LM test? It involves two regressions. The first is the restricted regression. Suppose the population model has 4 explanatory variables. The null hypothesis we want to test is that the population parameters of the last 2 variables are 0. They are multiple exclusion restrictions. The restricted model is as follows. We estimated and obtained the residuals mu hat. In the second regression, we regress the variable mu hat on all explanatory variables, including both included variables and excluded variables. This regression is called the auxiliary regression. We obtain the auxiliary R² from this regression. The LM statistic is calculated as the sample size n times the auxiliary R². The LM statistic follows an asymptotic chi-square distribution. We compare the LM statistic with the critical value in a chi-square distribution, or compute the p-value of the LM statistic to determine whether we reject the null hypothesis. Make sure that the sample size in the restricted regression and the auxiliary regression is the same. Since there are more explanatory variables in the auxiliary regression, its sample size could be lower than the restricted regression if data are missing from some excluded variables. In that case, we should use the reduced dataset, that is, the sample size of the auxiliary regression. Here is an example of baseball players we have used many times before. The model relates the players' salaries to their years in major leagues, the average games played by year, and 3 performance variables. The null hypothesis is that these 3 performance variables do not affect salaries once the other 2 factors have been controlled for. That is to say, beta 3 equals beta 4 equals beta 5 equals 0 in the model. They are multiple exclusion restrictions. We have applied the f-test before. Now we employ the LM test. In the first step, we estimate the restricted model, the model in which the exclusion restriction is imposed. The restricted model has only 2 explanatory variables. We save the residuals as a new variable mu hat, using Stata's predict command with the residuals option. In the second step, we run the auxiliary regression. We regress mu hat on all 5 explanatory variables. The R² from auxiliary regression is automatically stored. In the third step, we compute the LM statistic by multiplying the auxiliary R² by the sample size n. the LM statistic equals 26.92. From the statistical table, we find that the 1% critical value of the chi-squared distribution with 3 degrees of freedom is 11.34. The LM statistic is greater than the critical value, so we reject the null hypothesis at the 1% significance level and conclude that the 3 performance variables jointly have a significant effect on the players' salaries, after controlling for the other factors in the model. Alternatively, we can compute the p-value of the LM statistic using Stata's chi2tail function. It turns out that the p-value is 0 to 3 decimal places. It is strong evidence to reject the null hypothesis. Notice that we only regress the restricted model in the LM test. In comparison, the F test requires estimating both the unrestricted and the restricted models. The LM test gives the same result as the F test. Both lead to a p-value of 0 to 3 decimal places and reject the null hypothesis. We have discussed the LM statistic and the LM test. The LM test is for multiple exclusion restrictions in a large sample. It involves 2 regression models, the restricted model and the auxiliary regression. Thank you so much for watching this video. See you soon. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.